So in this first episode, we're just giving basic information about the OpenFOAM containers at Pawsey. So the first important information is the place where we are storing the maintained containers. So this is the path where those containers are. So it is group, singularity, Pawsey repository, OpenFOAM. So if you want to list the content of that, you basically just need to type to list the content. So ls whatever options. Here I'm using -lat and then group, singularity, Pawsey repository. Well, and I can use the tab, so Pawsey tab, and then O, capital O tab, and then enter. So those are the containers that are currently there. The main ones are the latest versions of OpenFOAM. So those are OpenFOAM v1912 and OpenFOAM 7. The other ones are there because I have been building some containers with older versions. And so I decided to maintain them also and to keep them as examples for users to build their own containers with different kind of flavors and versions. So you can perform a basic mini test of any of those containers. So the first thing you need to do, now we are in the bale A2. In the first step is basically load singularity, the module of singularity, load module singularity. Module load, I'm sorry, module load singularity. And then you can do anything you want to refer to the singularity image you are going to use, but the I don't know, the practice I'm doing is to set that name into a variable. So in this case, I'm using a lot in the scripts and in the command line, the setting of this variable, the image. The image equals, and then I know that images are in group, singularity, sin tab, and I think there are not too many subdirectories there, so we can keep pressing tab. We'll go to the next one, pressing tab. So those are the only subdirectories right now. But the idea is that possibly some other containers will be stored there for other applications like bioinformatics, etc. So yeah, right now we can just press tab all the way down. OpenFOAM, in this case, the example is with version 1912. Tab. So the naming is, well, OpenFOAM and the version, and then the third part of the naming is who made that container in this case, or who is the maintainer. So in this case, we are, and then that's set up. So now that I have the name of the image in this variable, I can make this mini test. So I need singularity to execute, singularity exec that container that is named in this variable, the image. So it's $the image, and then you can execute any OpenFOAM command that is recognized inside the container. So in this case, we are executing the solver icofoam, and we are just asking for the help of that solver. So this is a mini test that I do all the time, just to see if anything from OpenFOAM is being recognized inside the containers. And it's done, it's working fine. Now, this has created a bit of confusion, but yeah, anything that is not in the Veil region is nothing to be typed or executed, it's just information. So yes, you can have your own container. So whenever you build your own container, you are not going to save it in the Pawsey repository. You don't have permissions to write anything there. So you will need to save it somewhere where you have permissions to write. So I think nobody can see this this directory because this directory is mine. So I think no one will be able to list this command. But the idea is that in your own account, you will have your group space, your project. In this case, my project is Pawsey 0001. Then your username. In this case, my username is Espinosa. And then I decided to follow the same. I forgot the name for that, but the same standard for naming. So singularity. In this case, it's not a Pawsey repository, it's my repository. And then containers for OpenFOAM, and then I'm listing there what is there for me. So these are basically, containers are used for testing. And as you can see, there in the tutorial notes, there is a container from ESI and a container from the foundation, which are the developers of OpenFOAM. So those containers are the official developers containers. I have just converted them to Singularity. The problem with those containers is that we cannot use them, and we cannot use them in Magnus, and difficult to be used in SUSE. So basically, we need to build our own containers. I will elaborate a bit more on that later. And this is just another example for sharing containers with your group. Instead of saving them in your own personal subdirectory, basically you can create another directory starting from group, your group project, and then Singularity, group repository, OpenFOAM, and then you save there the containers to be shared with other members of your project. I don't know if you have any questions up to there.
It doesn't look like it. Alexis?
Excuse me?
I don't think so. I think we're good.
Okay, so let's keep going. So the next section in this first episode is about mpitch for the OpenFOAM containers. So we saw yesterday that Singularity allows you to run MPI applications with what is called the hybrid mode. So the idea of the hybrid mode is if you have an MPI installation inside your container that is compatible with the MPI installation that is in the local machine, you can use the libraries of the local machine to execute your job. You can still execute your job with the MPI inside the container. And indeed, that is the practice that is recommended by the developers to be used with their own containers with Docker. Use the MPI inside the container. But that gives a disadvantage. So why do we prefer to run with hybrid mode? Well, it is just because it gives better performance. And here we basically should offer only the solution that gives the best performance to use the computer. So what I have here, I think, well, I will, if you want to grow your tutorial window just to see the full table that is there in why do we prefer hybrid mode. So what I'm showing this table is the result of testing the channel 395 tutorial. I'm sorry, there is some noise in the background. With different containers. So the first container is the foundation container that is originally prepared with Docker. And I'm using the MPI, which is OpenMPI, that is inside the Docker container to run the tutorial. So I run it 10 times and took the average. So it took around 1,000 seconds to run. Then if I get the same container and I just convert it to Singularity and then use Singularity to run the tutorial with MPI, with the same OpenMPI but inside the container, we are not using the hybrid mode. We basically, in the host machine, you can say that there is no MPI installed. So if there's no MPI installed in your host machine, you will not be able to run in hybrid mode. You have, in this case, I'm using just the MPI installed inside the container. And if you can see, the time reduced substantially. This is just a small tutorial that needs to run with 4 cores. And if you use the hybrid mode, so if I installed OpenMPI in the local host machine and use the hybrid mode, then I'm using the libraries of the local machine, then the time goes lower again. So the more efficient way of running any MPI application is to use the host MPI. Now with the container I prepared for OpenFOAM 7 with mpitch on it. So I build a container with Docker with mpitch installed inside the container and run the case inside with Docker. It goes to, again, close to 1,000 seconds and then reduce with this just simple step of porting the container to Singularity, you can basically get a huge improvement. I think, well, I haven't seen that anywhere. I'm planning to write a sort of a paper about this, but now you are informed that basically one of the best things you can do is to convert your containers to Singularity. And then if you want even a bit more advantage, to run it hybrid. So there is a question, I think.
Yes, there are a couple of questions. The scaling test done with I/O or without I/O active?
The tests were done, I think it's just the plain tutorial as it is, so it is writing to disk, yeah.
Okay. So I'm getting quite a few pings on the side. Okay, OpenFOAM images, that'll be covered later. Marco, have I missed anything? I don't think so.
Can you hear me, guys?
Yeah.
I think this is the mic.
Yep.
I don't know how to mute here. But
we can hear Marco.
Here it is.
Yeah, no, so just one comment on what Alexis showed. So this test was done on a desktop computer, so what would be a single node on a supercomputer. If you run the same hybrid versus internal test on multiple nodes on a supercomputer, we will likely get even larger differences. because when you use internal mode, you won't be using the high-speed interconnect for communication, which you are instead able to use with hybrid mode. So if we don't have the figures now, but if you repeated this on Magnus, you would see even more striking benefits in using hybrid mode.
Thank you. And I think that was all the questions. Over to you, Alexis.
Okay, so then why MPH? Well, this is sort of a forcing by our computer administrators. Like Cray MPI is only AVI compatible with MPH, and Cray MPI is the only MPI installed in Magnus. I believe the reason is because when they did make the decision, they figure out that this is the best performant MPI available, and then they decided just to stay with it rather than using other flavors of MPI. That's what I always assumed until I was writing these notes, but I need to confirm that with the administrators. But should be something related to that. Cannot be that any more different from that. So this breaks a little bit the idea of compatibility of our containers, or being able to be transferred to any other systems. But I think that's true with any kind of MPI application, because if you want performance, you will always need to run hybrid. And if you want to run hybrid, then you will need to be AVI compatible. So that's a problem with MPI, and a problem that the solution that was found to have best performance is the hybrid approach, because that sort of basically fix the implementation to the computer you are planning to use your container. But well, that's what we have so far. So yeah, the main problem is we cannot use the already published OpenFOAM containers from the developers of OpenFOAM, which have OpenMPI in Pawsey and in Magnus. And the other problem that I think, yeah, it's sort of a big problem, is that we need to build our own containers from scratch. But I guess many of the of people interested to build their own containers is people interested to run all versions of OpenFOAM. So then that's there's no other way to go but with suffering with the installation of the old version, or preparing your own container. So it's basically, you cannot get rid of the burden of dealing with all versions of OpenFOAM anyway. Okay, so there is a bell, so it's time to type a little bit. So basically, the idea is for you to check just what does the module of Singularity does, which variables it sets. So you can do module, you can type module show Singularity. And there you will see the definition of the Singularity variables that are used to make this hybrid mode work. Yeah, more information about the hybrid mode settings are in the Scilab's documentation. And if you go there, you will see that these two variables, Singularity bind path and Singularity LD library path, are the main two variables to be set to be able to run in hybrid mode. And that is being done for you with within the module of Singularity. So Magnus and SUSE are ready to work in hybrid mode. So then you can check the version of MPI that is installed inside the container. So we can do singularity exec. We already have the image in this variable, the image, and just MPI exec or any other means for checking the version installed. So the version installed inside the container is mpitch 3.1.4 and some other information about that. What else we have here? Yeah, so just the key points. A singularity image is just in simple terms, it's just a file. So once you have created your singularity image, you can just transfer it anywhere you want. But we recommend you to use a defined policy within your project, within your group, just to know where the images are and share them rather than people having the same image in different directories. OpenFOAM images maintained by us are in this directory in group singularity Pawsey repository OpenFOAM. And containers, any kind of container that needs to run an MPI application needs to be equipped with mpitch for running on Craze. I'm fixing this just to the Craze because, well, you should be in principle able to run OpenMPI applications on SUSE, but that will need to change all the settings that are in the Singularity module. So the Singularity module is just prepared to run with mpitch. So yeah, we prefer you to build your own containers with mpitch.